these are the 5 changes, the primary changes. Of course, there's more than this, but the primary changes are in extending Last Planner to taking on what we used to call project controls. As project controls having the job, performing the function of identifying project objectives and assessing whether or not the project is on target for achieving those objectives for scope, budget, time, etc. Right? And then in order to do that, we needed some new metrics, and I will talk about that. Specifically, metrics concerning whether we are advancing the project appropriately. And then LPS, the LPS stands for Last Planner System. Should explain that. So the Last Planner System, LPS, was conceived to be neutral with regard to work structures, right? And so we said we didn't say that we didn't recognize the fact of work structuring, and nor did we say that we thought it wasn't useful, but we didn't take a position on the different ways of doing it. And so we're now taking a position that where appropriate, we recommend using location-based work structure, and I'll explain that. That I actually had one of the, I've forgotten, I'm sorry, I don't have the name to hand, but one of the people who asked a question, sent in a question, was already doing TACT planning, right? So I think my guess is that it's loose in Denmark, and so many of you may already understand that. The fourth one is concerns the function of learning from breakdowns, and I think that's been one of my disappointments, is that hasn't always been done very well. And I think that I'm trying to do something from our side, from the kind of systems design side, to deal with that. And I'll explain what they came up with, what this research team came up with. And then this is a smaller one, but Last Planner System applications and design. And there's been it's been used very well and effectively in many cases, but there's enough cases where it's been either resisted or there have been concerns about it that we needed to take a look at it. And so I will go through those in order. Okay, so this is, and I'm going to look at my notes here because this is a complicated one. So, so the idea here is to really have a process for project execution planning. And we're thinking of project execution planning as occurring at the end of project definition, prior to and informing the go no go decision about the project. And what we're trying to answer is, can this project, as we've so far at that point defined, with its objectives and its constraints, budget, time, and so forth, location, can it be executed? Can it be delivered with acceptable risk? There's always some risk, right? And so that's what we have come up with. So it starts with some readiness requirements for starting the project execution planning. As the client and project stakeholders are aligned on what's wanted and conditions of satisfaction, have they gone through the process of establishing what's wanted at an allowable cost for that, and then testing the fit between allowable cost and expected, right? And that kind of works on both sides, right? It works on your plan for delivering the project, but it also works on if you're not confident that that's going to be possible with those targets, then you change the targets until the point where you're no longer you're cutting into muscle, right? So I've come up with more recently the idea that they're mission critical is a key concept here, because some projects will not exist, will not persist, will not be delivered if they can't accomplish some specific mission, right? And so if you're doing project execution planning and evaluating the viability of a specific project, then you have to know, well, what is mission critical? And you have to also know, of course, what are the targets for delivery of value to the project stakeholders. So the next, just moving through the diagram. So if we've got presuppositions, preconditions have been satisfied, then you, one way or another, you pull the master schedule and creating a logic network and check it against budget. Okay, so so we needed a process for doing that, and that's a process that is provided in the 2020 benchmark. From there, identify risks and opportunities to be avoided, to be buffered, to be hedged, and to be exploited. And so I'll come back to this in a moment, but the idea here is that not all risks can be buffered. And so we want to introduce some elements of stochastic planning, that is planning in conditions of uncertainty, specifically around what's called hedging or options, right? And I'll give you an example of that, a simple example that we generated to explain how do you assess whether or not your option or options are really of value. That is, not all of the things you might consider doing will be viable. So it may cost you more in time or money, right, than you can save. And so that's one of the changes involved in the application of Last Planner. Coming out of that, develop mitigation strategies, revise budgets and schedules accordingly, and then explore possible changes, and ultimately submit for validation. And that validation is by means of generating a plan for executing, delivering the project, and assessing residual risk, right? And that, of course, might go around until you come to a decision. All right, so let's go. So we started in thinking about extending Last Planner to managing the project, right? Are we on track for delivering what we are, hitting our targets within our constraints? And what we've realized with that, in current project planning, there's often a weakness that they only provide a single pathway to objectives, even though we live in highly uncertain, in the midst of uncertainty, and sometimes uncertainty even about things as fundamental as making a major decision, right? And so we looked at that, and we had a team that worked on that. I probably had, in the 5 teams all told, I think we had more than 50 people, okay, working for 2.5 years. Another weakness that we identified was over-reliance on buffers. And so as I mentioned, some types of variability can be buffered and some can't. If they're statistically predictable, that is, if you can develop a frequency distribution, then you can calculate a buffer size, right? But if it's not statistically predictable, then you can't. And so we tend to use buffers as kind of a single solution to a problem that has different faces and requires different types of solutions. So just to share what we found, this is not from construction. This is from this is a supply chain for Ford Motor Company that's highly abstracted, but But basically what they've done here is they've mapped their supply chain. So you can see on the left, suppliers of printed circuit boards, chipsets, raw material suppliers, and these are going into different places along the way, all the way down to into the assembly plants for Ford, right? And what they did was they took on the job of assessing the what would happen. Say, well, what would happen if one of those? Let's think of each of these as a light, right? What if that light went out, right? How would that impact the overall system? Right? And so they developed a risk exposure index, which is from. Then they would say, if it does go out, how long would it take to get it back going, right? Back in operation. And so what they were trying to do was and they weren't trying to predict whether or not it would go out. They were trying to create a stronger system, more flexible, more resilient, that in case any of those things were to happen, right? And so it's really, really an interesting approach. We don't have a solution for that applicable to construction yet, but we're working on it. I just thought you might be interested in that. Okay, the benefits of using the risk exposure index: it provides a dollar measure of risk. It's based on the entire network. It avoids the need to forecast the unknown. It forces a discussion to understand why time to recovery for similar facilities or supplies is different. It forces a process to reduce time to recovery in various stages of the supply chain, and it makes sure you have a good understanding of supply chain dependencies. And so we're thinking that it's not just applicable to supply chains, but it could be applicable to an individual project, because we sit within supply chains, right? And they feed us. And if we Anyway, that's enough of that. So, okay, so the idea then is to build alternatives into your schedules. Okay. So projects always, I'm going to read here, you can too. Projects always have lots of uncertainties. For example, a major decision might be reversed or delayed. Why not just add time to your schedules and money to your budgets? Increase project buffers. Remember that waste is any cost item that can be eliminated without reducing value delivered. Is buffering the best way to manage uncertainties that can disrupt a project schedule? Buffering is a good way to handle uncertainties that are statistically predictable, so the right amount of buffer can be calculated. That doesn't work for delayed decisions. Alternatives, perhaps call them options, require pre-work which has a cost. How do you know if the cost is worth paying, right? So that was the question we set out to answer, that is to provide a method for calculating that cost in time and money. Right? So I'll share that, what we did. So one of the people on our team was the general superintendent for a construction company based in South Carolina, I believe, Robbins and Martin. Bill Stevens is his name. And so he was able to, we took a project that had been completed so that we had all the details about it. We knew all the costs, we knew the schedule, okay? And but then we, so this is a concept, right? A concept solution. So we suppose that waiting for better information about the demand for dental operations, and hence the type and number of dental equipment, would have been valuable to the client, right? And in fact, as Bill said, it actually would have been, but we, so this is a possibility, right? And what I see if I can explain this well, or at all. So there are three different possible actions, kind of strategies, if you will, about such unpredictable, you don't know what you don't yet know, right? Unknown unknowns. And you can either guess and do nothing, just right, just to hope that it turns out, right? You can, if it goes wrong, if something comes up, say they discovered that the assumption about demand for dental services is incorrect, that you discover that later, right, after you've already gone down the road, right, quite a ways, then you're going to have to do rework, and that's going to add time and money to the project, right? And then the third thing is to develop a plan for collecting that information as quickly as you can and putting yourself in position to take advantage of that information. Okay, and that's what we supposed in this case. And there were three different options to be done in order to execute that proactive strategy. So prepare the foundation floor plan to enable quick installation of different types and different number of chairs, increase space, specify easily remove flooring to install equipment support. You guys are the professionals. You can imagine how that would go on. The second one is take steps to determine actual demand for dental equipment and chairs. Exploiting this option identified the dry-in milestone as the time for arrival of information. Okay? And I will show you a snippet of the schedule so you can see. A contract with key suppliers to deliver more and different equipment at a given time if needed. Okay? So that's what we were doing. And these are lists of tasks affected by change in dental equipment type and quantity of chairs. Okay? So as you can see, if we're going to get, so you can see that we go all the way. So dry in, we said, is when we're going to get the new information. That's at task 47, right? So you can see that we're impacting construction. And so it's not, it's bad enough if you're just impacting design, but if you're impacting both, then you're talking about potential a lot of money. So here, so case 1, 2, 3, or across the top there, represent these three different strategies. I'm calling it deterministic, reactive, and proactive. Right? And on the left-hand side, from that previous list, right, these different schedule items, those are the numbers of tasks that are impacted or involved in the sub-project designing and delivering the dental surgery suite. And so case I, number 1, would be so each unit 0.25 equals 1 unit of duration is equal to 33 days. So that's 0.25, 1/4 of that, right? So if you sum up those different durations, you get the total duration for this sub-project of 2.25, right? For case 1, the deterministic case. And that's how long it would be added to the project if you got lucky, right? You guessed right. Now, case 2 has that same set of numbers, right, for do, but they also have the time spent on undo and on redo, okay? And we did these to the best of our ability with Stevens and his people so that it would be a fair assessment, right? So, but that would sum to, I think, what that was, well, 6.7, a little bit over 6.7 times 33 days, right? Okay. Now, so case 3 is the proactive one where you can see if you compare the sum of times, durations for due first stage, meaning before the delivery of the new information about demand for dental equipment, it's only 1.5, and it's as opposed to 2.25, right? And that's because you're delaying things that can be delayed and would be impacted, design specifically, and of course deliveries, would be impacted by a change in that demand estimate. Right? Let's see. Okay. And then there's additional 1.4 for the second stage, which is what you do after you have the correct information about demand. Right? So this gives us a way of comparing 1.5 and 1.4 is 2.9, right? So 2.9 would be a longer duration than 2.25, right? But 2.25 is only going to happen if you guessed right. So we did the same thing for cost, and this is the result for the comparison at the end. So this is a comparison of sub-project durations on the left and of sub-project costs on the right. Right? I hope people are with me. If there's no questions being asked, I guess they are. Okay. Okay. So this is basically a process for a method for assessing whether or not an option is worth doing. Right? And I think that, well, it's speculation, I guess, but it seems to me that we should have this weapon in our pockets, right? Have this in our arsenal, use it. But remember that just because you have a good idea doesn't mean that it's worth doing. Okay, new metrics for LPS. So here. So I've got this is again a build. So I'll just take it on myself. When I first developed the last planner system, I had worked for Brown and Root and then for Bechtel out in the industrial sector, and I think we knew what tasks were critical, right, at any point in time on the project. Of course, it gets gnarly when you're beset by changes. Things are very dynamic, changing all over the place, right? But I assumed that last planners, frontline supervisors, would naturally first allocate capacity to critical tasks, right? And I've been told that I was wrong. Now, I don't know for a fact if I am, but it made me think about, well, what was I assuming, right? What were my presuppositions in making that assumption? So one was that the project as a whole knew what was critical, and the frontline supervisors knew what was critical. And if they didn't act on that information, following the rule to first allocate capacity to critical tasks, then their supervisors would check it and correct it, right? And teach them the importance of following the rule. So the possibilities seem to be that either it's not known what's critical, or it's not known by the decision makers, the frontline supervisor, right? And it may be that also that the rule is not made explicit, even though you would think that it would be plain as potatoes, right? And are enforced. So the fundamental metric that has been developed is called commitment level. It measures the percentage of required tasks that have been committed on weekly work plans. Anything less than 100, and you would do this provisionally, right, as you're looking ahead, and so that you still have time to fix it. Anything less than 100% triggers a search for reasons. Are we short of capacity? Or some required task not made ready? If either of these apply, that triggers countermeasures, including replanning to overcome the delay. If neither of these apply, work commitments are changed so that available capacity is applied first to critical tasks. Now, I'm a firm believer that we want the project to be managed by the people doing the project, right? And I don't want this to become a kind of big brother phenomenon, right? Where we're looking over people's shoulders. But we want to use it to make sure that as project manager, project leaders, that when we're asking people to behave in a certain way, we're giving them the necessary skills and information, right? And so I think of this as really measuring our ability to do our job in the last planner system. Okay, so there are two other but connected metrics. Milestone variance, and that's of course a function of whether or not you're performing critical tasks, right? You're completing critical tasks when at the time they have to be, at the last responsible moment. So is the number of days at milestone projected to be early or late, right? And percent required complete is a percentage of required tasks that the team completed in the prior weekly work plan, regardless of whether the team committed to completing them or not. Right? So I think they're all really one metric performing one function, right? So that is a change in the last planner system that's coming out. So the third one, as I mentioned before, concerns work structures. So previously, and we used the language LPS 1.0, LPS 2.0, it just stuck for some reason. So no work structure, specific work structure was specified. Here we're proposing location-based work structures. Handoffs between trades were completed tasks. In this case, it'll be completed areas, right? Tacked zones, tacked areas. So it'd be very relatively small, depending upon what your tack time is. Right? I'll show an example in just a minute. So in order to avoid clashes between trades, you're doing that task by task. Here, we're trying to do it area by area, where trades have areas to themselves. And so this is just to introduce, as I mentioned earlier, I suspect that you don't need this explanation, but a tacked plan is a way of structuring construction work like an assembly. Right? So, in an assembly line, the product that's being assembled moves through different workstations at a slow rate, right? Or sometimes it's even jerked forward after a certain time, but let's just say that it's moving continuously, and when it's within a certain space marked out along that line, the workers are adding different things to the automobile or the product, whatever it is you're building, right? And so to know that, you need to know how to structure that. You need to know what your demand rate is, what your throughput rate is, right? And then most assembly plants now, automobile assembly plants, they produce one automobile every 60 seconds, 60 minutes, every minute, right? So, and then you need to know the sequence that your design and the nature of the product allows. What are the sequence of tasks so that you can bundle them together, right, appropriately, so to form workstations. And so we'd use the same approach in developing a tack plan. Right? So, but the problem, of course, is that it's inverted, it's inside out, because the types of things that we build in the construction industry get too big to be moved through workstations. So we have to move the workstations through the building or the bridge or the whatever it is, right? So this is from, I think it's a hospital, it doesn't matter. It's a floor of a hospital, and you can see on the right-hand side the structure. It's color-coded by the areas into which it's been divided. And then for each of those areas, the sequence of trades is indicated with color coding. And the trades are identified at the bottom there. And so you can see that when this works, one of the fundamental things that it does, well, it does a couple of things. It allows the trades to work without banging into each other, right? But fundamentally, it enables you to predict with some accuracy, a high level of confidence, what work you're going to be doing X number of weeks ahead, right, or days ahead, or whatever the tact time is. In this case, the tact is, I think, 5 days, the regular work week, right? And that allows you to structure and manage flows of materials, information, pre-assemblies, right, to the job when you need it, right? So you don't have to have everything laying around to hand. You, on a recently completed large hospital project in downtown San Francisco, during the appropriate phase, the fabricated items like sheet metal, right, ductwork and so forth, were delivered in the night from a fabrication yard or to be installed the next day, right? So it really makes life more livable. So I thought it might be interesting just to spend a moment to talk about how do you buffer, because we've been talking about how do you manage variation, right? How to buffer a location-based work plan to accommodate expected variation. And in this case, for a TAC plan, all buffer types can be useful: capacity, time, and inventory. So capacity buffers are useful for accommodating variation in the amount of work for a trade in the areas. So that's one of the challenges in TAC planning, is you're trying to size capacity to the extent that you can, so that for each trade, so that each of them are within the allowable time for them to perform their work within the TAC areas. That is, those locations into which the job is divided, right? So capacity buffer for almost all of the trades will mean that they have a little more, they can do a little bit more work than they have work to do, because you're trying to hit those handoff deadlines. And so, yeah, just to remind myself to say, so when a TAC plan works, you essentially solve the problem of reliable release of work between trades. But in order to do that, for it to be reliable, you have to have a reliable release of work within trades. So, and that goes to the idea of specialization. And so the more fully skilled your craft workers are, the less that problem is going to be, because otherwise you have, it's a planning problem, right? So time buffers can allow taking time to recover from delayed completions that were not avoided. Okay, and that does happen, and take time to reconfigure the location-based work plan and restart. So what we're advocating here is that you have a buffer in your overall TAC plan for a phase of work, and it'll be different for different phases, obviously. So that, first of all, you want to try out, to the extent that you can't simulate it, you actually try out a TAC plan, and discover where there are problems that need to be smoothed out. And you need to allow time to do that and to restart without endangering hitting your end date for that phase. Okay? And then inventory buffers can be provided by reserving specific areas as fallback work for each trade in each construction phase. This removes some areas from the location-based plan, but allows productive use of otherwise lost capacity. But I should have, to be more exact, I should note that there are other uses for otherwise lost capacity that may not be directly productive, but are useful uses of training, design of future operations that haven't yet been designed and haven't yet been performed, or improving operations designs that have been performed, but where you discovered that there was something that could be done better. Right? Also investigating breakdowns, things that haven't gone right, doing analysis there, and we'll talk about the 5 whys in that connection in just a bit. Oh, there we go. See, okay. I don't remember my own slides. All right. Okay, now LPS and learning from breakdowns. So let's see what we got here. Okay, so I'm curious. If we were in person, I would ask you to raise your hands and answer to the question: are you satisfied with your organization's learning from breakdowns? And I would hope, for your sake, that a lot of the hands, maybe all of them, go up. But in my experience, that if you're being honest, you're probably not satisfied. Right? And I think that I can take some responsibility for that. I don't think we've been as explicit and clear as we could be about providing the process for learning from breakdown. Breakdown is any unintended outcome, right? Whether it's good or bad, right, of an action. So that gives us, when we have a breakdown, that's a signal that there's something to be learned, right? Either to avoid something negative or to embrace something positive. So I don't think we've been very as explicit as we can be in providing a process for learning, in specifying roles and responsibilities for doing it, and in emphasizing the need to reserve capacity for people who are to perform those different roles so that they can actually do them. Otherwise, the forward impetus of the project will just sweep everything along with it, and you tend to miss those opportunities for improving. Okay, so this is what this group came up with, and I'm going to. I don't have here, but I will include in the 2020 benchmark examples of what people are actually doing that's working well. So organizational processes, psychologically safe environments. I'll come back to that in just a second. Guidelines for selection and investigation, countermeasures, development of countermeasures, tracking success or failure, and then keeping track of lessons learned. So this will all be specified in the document. And if you want to read this, you can read each one of these different research reports. They will all be on the website of our research center, Project Production Systems Laboratory, P2SL, where where 2 is the number, p2sl.berkeley.edu. Okay. So, and I will give that at the end. And so they'll be in the slides, which you will get, so you'll be able to track them down. Okay, so clearly define the process. And obviously what we're trying to do is to, through the use of different methods such as 5 whys analysis, to identify countermeasures that would prevent that problem from reoccurring, or at least reduce its negative impact. Okay? And then clearly define who has what responsibilities in each step in the process, provide sufficient capacity. If failures are frequent, provide guidelines for selecting which failures to investigate. Ultimately, we'd like to make it so that the failures are so infrequent that you always investigate a failure. Use visuals to communicate progress through each step in the process. So the question for you is, has your organization done those things? And if you have, I'd really like to know about it and to learn from you. So this idea of psychological safety, I don't know if that's a term of, that's a recognized term in Denmark, but I learned about it from, I was starting several years ago, maybe 5 years ago, I was starting a construction safety research group, research project. And my good friend, Greg Howell, who's only recently died, suggested that I look at it's like an 11.5-minute video, YouTube video, on which you can get by searching YouTube for psychological safety. And you'll probably get this video, or one of Professor Amy Edmondson from Harvard, who came up with this term. And she's really developed it into what's called a construct, right? So a concept that has connections, tendrils out into their implications. So, but she's in that video, she tells a story. She says, imagine that you're a nurse taking a medicine to a patient. You're on night duty. You happen to look at the dosage on the medicine, and you go pale. My God, that would kill her. I'd better call the doctor and make sure he didn't make a mistake. Then she starts thinking about what happened the last time she challenged that doctor about something he told her to do. And she starts talking herself out of it. She didn't feel psychologically safe. And psychological safety doesn't necessarily mean you think that you're going to get hit over the head with a brick, right? But you expect some type of negative reaction, consequence of speaking up. And I think that in good faith, all of us have moments in our experiences when we wish we had, but we didn't speak up, right? Because we didn't feel safe. And so what we've started to do with, let me just finish Amy Edmondson. So Edmondson has, once she discovered that concept, right, that problem, she started working on developing ways to measure it and ways to improve it. And she connected it. She was able to show a connection between this feeling safe to speak truth to power, feeling confident that if you make a mistake, you'll get help, not harm, those kinds of things, right? Learning behaviors are made possible when people feel psychologically safe, right? And if your teams, and she did her research on a number of different types of teams, but mostly a good example of it is medical teams, like working together in a surgery, right? And it turned out that they made fewer errors than teams that didn't feel psychologically safe, working with one another and speaking up, right? But they caused less harm, because they were able, by working as a team, to identify a risk, right? Where's the scissors? Did we leave them in, huh? No. So to intercept those hazards, if you will, and defuse them before they explode, right? To use an image from a bomb, like a missile blowing up something. And I think that's what we want to do. And I know that's what we want to do with regard to not only physical safety and health, but also with regard to every other kind of work that we do. And so we've taken that from the realm of industrial safety and applied it more generally to, and I've connected it. I've been able to connect it to the lean principle of respect for people. As respect for people does involve being courteous, being respectful in that sense, right? That's not negligible, but it's fundamentally recognizing the responsibility to help people develop, teams and individuals, to help them develop their capacities. Right? I think in the U.S. Marines, their slogan is "Join the Marines and become all you can be." And I don't know if they do it, but that's what we're trying to do. And so there's this really a causal connection between psychological safety, learning behaviors, and team performance. And teams that have been measured to be not only more efficient, but also more effective, deliver more value, and more flexible. So they're better able to absorb change and react to change, right? And I think that there is some data that that's one of the consequences of the last planner system, that people who are doing it well, companies and organizations, projects that are doing it well, tend to become more effective, more efficient, and more flexible. So better able to execute, develop plans and to execute them, but also to replan when necessary. And it will always be necessary. We're just trying to make it not chronic. LPS and design. I think this was the least impactful of the teams, the research groups that worked in on these changes. But I'll just share a few of the things that they looked at. So they're thinking that we haven't. So they're thinking that the training and the delivery of the last planner system needs to be customized for design. And they did some data collection and with designers, and those who were doing it, they looked at the relative distribution of time. And so they were saying that they found that most of the time is spent on pull planning, right? So 40% of the time on should, very little of the time on learning and improving, and then the 25% design cycle planning. That's refers to the look ahead planning phase of the design of the last planner system. So their recommendations on the right-hand side, they noted that there were two different types of design work. One type is more akin to making, so detailed engineering, right? Which can, by the way, be done using location-based work structure, right? But regular design proper is probably not so easily divided up by location, though some of it can, like developing room data sheets, right? So, but then how do we specify design milestones? And they had some ideas about that. But the one that they really focused on was reliable promising. And so I thought it would be appropriate to talk about that pretty quickly. So I assume all of you are familiar with this idea, the term at any rate, and you're probably even more familiar with the process. But let me say a little bit about it. Okay. So the picture is I've amplified it a little bit with the list on the upper left. So I'm thinking that there really is a process, right? And it starts with someone, we'll call them the customer, making a request of someone else, which we will call a provider. And this can be in the context of developing a work plan, right? Or it could be for example, we're applying it now in the development of any team that has a deliverable. For example, when we're developing the quality requirements for a specific type of one element that's produced in the project, and then specifying how you're going to assess the conformance to those requirements, and then how are you going to develop a process, work method that is capable of delivering to those requirements. And that's really a complex set of reliable promises. So what happens when the customer makes a request? So the first thing is to make sure that both parties, or maybe more than two, but let's just simplify it to say two parties, that they both have the same understanding of the request, right? So you don't go back and say, unless you're absolutely certain that you know what they want and you understand why they want it, right? You don't just say, yeah, I'll do that. But first you take the precaution of, let me just say back what I'm hearing you say and what I assume that you mean by it, right? And once you've got that done, then you go into a kind of negotiation, right? Again, if you can immediately say yes because you're confident that it both should and can be done, make the commitment, right? But more often than not, there is some type of compromise required, right? And so what we've advocated is that, you can't say no if you can't make a promise. Well, we actually advocate that you don't say no, and most of the time you say yes if, right? Yes, I will do what you're asking if I get the materials on Tuesday morning. Yes, if I get the soils report, ... right? But you might also make a counteroffer. You could say, well, I can't do what you're asking, but I can do this part of it. Would that be useful to you? Or you might come back and say, well, if I'm understanding what you're trying to do, I think you're asking me to do the wrong thing. What you really need would be better accomplished by doing X. And okay, so you're really treating people, customers, like they're customers. Mm-hmm. So those first two things: request, clarification, negotiation, then commitment, right? Then a declaration of completion, I'm done, and then a declaration of satisfaction or dissatisfaction. The customer might come back and say, excuse me, but we agreed that you were going to do X, Y, Z, and you've only done X, Y, or you've not done it in a certain way that was agreed. And that might be an occasion for learning again how better to perform this process. Because, well, I did what I thought you wanted me to do. Where did we go wrong? Okay, so the declaration of completion and declaration of satisfaction are really critical if you want to learn from this process, just like we learn from designing direct production of design and construction.